time is probably one of the most ignored dimension, especially within RAG and knowledge graphs. But time shapes the data validity and also the context. So every data point exists in a temporal context that affects its reliability, but also its usefulness. And a common pitfall, so for example in cybersecurity, when we use a week-old threat intelligence, we can miss new, for example, zero-day exploits. In legal, if legal teams reference an outdated contract or outdated regulation and laws, we might risk really costly disputes. Engineers which work on a stale API documentation introduce bugs in their system and the API contracts break. So we really have to timestamp all data operations, ingestions, updates, observations. So at the least, this is usually 3 different columns: created that, updated that, deleted that, for the different rows within our tables. And if we can, we should even try to implement something like versioning, where we actually keep the old data as well. So instead of updating the existing record, we create a new one with the updated data and mark the old one as deleted, but keep it in there so we have this lineage. And across this, we shouldn't treat data as perpetually valid. So in today's conversation, we'll be talking to Daniel Davis, who is working a lot on temporal RAG, how he calls it. So basically how we can bring a time dimension to retrieval augmented generation and knowledge graphs. And he puts data into 3 different buckets. And each of those requires different handling. The first bucket is basically observations, which are measurable and verifiable recordings. So it's, for example, I'm wearing a hat which reads Sunday Running Club, and it might be Daniel notices, okay, the hat has a text on it which reads Sunday Running Club. This is an observation, but it requires supporting evidence. The second part, assertions, is more of a subjective interpretation. So for example, he could say the hat is greenish, which might be hard to verify if you're only listening to it. So you would have to basically trust his assertion. But it always requires confidence levels and usually also update protocols. Facts are immutable and verified information. And the immutable part makes facts very rare. And this is especially you need a preservation protocol, that the fact can persist through time and isn't updated. Otherwise, it would fall in the other 2 buckets. And these differentiations, we will go deeper into that on how you can use them, basically allow you to distinguish a little bit between static and dynamic data. And you will realize that most of your data is dynamic, so you should treat it as such. So you should add the time dimension and monitor also the data freshness systematically to see whether data has become stale, and also review and update your data regularly. And when you get into the really advanced space, I think what is really interesting to me at the moment is, for example, how can I make it that the dependencies between 2 different parts of the system, so for example, the code and the documentation, which both have different lineages through time, how they are updated, they also refer to each other. Because if the code base changes, but my documentation doesn't, I have a break in the dependency. And I can only notice that if I take time as an extra consideration into it. And both of these principles basically work together, or both of these frameworks. So we should good data isn't just about storage, it's also about maintaining the integrity and usefulness over time. And today we will be looking at how we can actually embrace time as a core data dimension, how we can differentiate between observations, assertions, and facts, but also how Daniel at TrustGraph, how they build their knowledge graph and how they basically favor simplicity and modularity over like really elaborate taxonomies and ontologies. And let's do it.
Time doesn't really factor into a lot of the ways that things are done right now in terms of architectures that we see in AI frameworks, platforms, whatever it is that people are calling them. And there's a lot of opportunity for time. And also just in information itself, time is one of those factors that often get overlooked. I've seen that so much in my career, though. I spent a lot of time in the risk world doing, risk assessments for really complex systems. And I've argued for years that time is really important factor of a risk assessment because it changes over time. Once you do that assessment, you kind of planted a flag in the ground and said, this is as of today. 6 months from now, 10 months from now, 2 years from now, this is probably not true anymore. And there's not a single risk framework that I'm aware of that actually takes time into account. There's a lot of work like that, in fact, that just doesn't take time into account. And that's something that we at TrustGraph are really looking to do in the near future.
How do you actually want to integrate it? Maybe let's start first with the issue of knowledge graphs that time really isn't considered. Like, where does it come from, and why isn't putting time as an attribute or as a type of relationship, why isn't that enough?
It's a pretty difficult problem to solve because if you think of a really large document, you have a 200-page PDF, because I have one I've been working with a lot lately for an article I'm actually writing to do some comparisons. It doesn't really have much time data in it, except maybe on the very first page. You have a date in which the document was issued. But if once you get into page 364 and the topics on that page, there's no time information anymore. So you don't get any information on how fresh is this knowledge or this data or this information, this observation, this assertion. You don't get that data. So the only way to really handle that is, in a lot of cases right now, is manually. With document metadata, as you're doing an ingest, you can begin to, well, I can distribute metadata on, is there a date somewhere in the document? And at the very least, I can say, we ingested this document at this point. And so you have that point in time. So I think when you look back at historical information, there aren't really good technological methods and solutions to extract that information that might not be there. That's why you want to get this information into a system going forward that is able to manage that time. Because once you get the data into the system, you have to maybe, plant that flag in the ground and say, okay, we don't want to have a lot of temporal data previous, but now we do. So now we can begin to say, it's fresh as of now, but what happens going forward? Are we seeing new information? Are we seeing updates? Are we seeing information that conflicts with what we already have? And then you're able to start to calculate, how fresh is this data? Is the data stale? Is the data static? Does it never change, or does it change slightly? But I think that's something we're just going to have to accept, is that there's always so much we can do with the past, and we just have to really focus on, what we can do with this information going forward. It's a big transition. We've seen technology transitions like this in the past where, it's a paradigm shift. And part of that paradigm shift is there's the before time and then there's the after time. I used the word time a
Can you
lot,
maybe
didn't I?
Yeah, you did. Can you maybe first define like the three different terms you used? An observation, a fact, and an assertion, and how you would define those? And also, how do you automatically differentiate between them?
Two of those I think have pretty straightforward definitions. One does not. So observations and assertions, pretty straightforward. An observation is, I think about it a bit like in the quantum mechanical sense, in that you don't really know the state of a system until you make that observation. So an observation would be you're wearing a hat that does, I think it says, is it say Sunday Running Club? Is that what it says?
Yeah.
Okay, so that's an observation. And an assertion would be, I think it's green, which I think on my screen it looks kind of greenish. So the distinction between those is an observation is a recording, something that I can measure, where an assertion is more of a human opinion, a human statement that my opinion about particular time situation that doesn't have a supporting observation. So that's the way I look at those two. An observation has to be supported by some other piece of information, whereas an assertion is what is not. Now, fact. Oh boy, this is something that even my co-founder, we don't exactly agree on the definition of this, but we're working towards one that we mutually agree on, because it's something that can get so complicated so quickly. And I find so concerning that the majority of people today think it's a really simple definition. They think facts are these black and white things. And if you talk to anybody that's worked with really complex information, worked in the intelligence world, for instance, they will tell you that there's no such thing as black and white fact. Everything is this gray area. So I started giving this a lot of thought. What is a fact? Well, we can start thinking about facts that observation that is supported with evidence or some sort of information. Okay, that's a starting point. But what happens, what changes? And we see this all the time. I think about the LA, the California wildfires, and there's a lot of information coming out about that. People are making a lot of observations, and they're not necessarily trying to be malicious, but the information changes over time. As we get more information, some of the observations may not have been completely accurate, or there might not have been fully detailed. There might have been omissions. There might have been disambiguation. There might have been misunderstandings. So what do you consider a fact in that situation? I think that's a really good example, the LA wildfires. What do we consider facts in that very rapidly changing situation? And that's where time comes in. I started thinking about this and I went, well, a fact is going to be something that no matter how many times we talk about it, it's never going to change. It's static. It's like geological bedrock. When you talk about archaeologists and geologists and they dig and they hit bedrock and they stop. Why? Because you've hit bedrock. There's nowhere else to go. You can't dig any farther. And I think that's, I don't want to say the only way, but I think that's a way that we can look at stat in a more granular way that we can work with going forward in time. Again, we haven't used the word time a lot, is that it's something that's never going to change. Like, for instance, my observation that you're wearing a hat that says Sunday Running Club. If I say during our podcast episode, you're wearing a green hat that says Sunday Running Club, well, that's never going to change. So that's a fact. Now, if I say your hat, well, what can I say? Like, if I made some sort of assertion about how I think you're feeling right now, that's an assertion. And also you may tell me later on, like, well, I didn't really feel that way. So that's an assertion that may change over time, an observation that may change over time. But the fact that, well, there I go. See, we have all these words that we struggle to describe these situations without using the word that we're trying to define. So the observation that you're wearing a green hat during our recording that says Sunday Running Club, that's never going to change. So that's static. In our thinking, we would classify that as a fact. Now, you can get much more granular, much more detailed. You start getting degrees of fact, degrees of truth, which I'm a little bit frankly, the word is scared to go down that road. I want to create a relatively simple system, at least at first, that I think people can understand. Because I think people can understand that. I think people can understand this piece of information is never going to change. It's etched in stone. It always was true. It always will be true. And when you start thinking about it that way, you realize there aren't a lot of facts. Most things can change. And that's why fact, the world of fact, the world of information, disinformation, is so difficult to understand because there is so little information that is truly etched in stone. Everything else is dynamic. And when we start to accept that information is dynamic and keep track of it, keep track of how it's changed over time and keep track of how often did it change over time. Is it changing over time rapidly during this period and not over here? That gives us a lot of information to be able to determine, well, do we trust this information? And, that's a lot of words that ambiguous, controversial, and conflicting, definitions. I think that with AI and AI systems and how we're trying to use those and the availability of information neural, these are imperative problems to solve.
And then for the rest, like especially for the assertions, are other factors coming into play, like consensus, the confidence, or the authority of the source. Do you handle that on top of it as well, or do you want to handle it?
I I think my view on that is I'm I'm undecided on that, I guess, is I'm gonna give the politician answer and waffle and say, I don't know, maybe. I have well, okay, let me talk through this for a second because my mind is racing because we could go in this in so many different it's value actually on both sides. From a system designer in a trustworthiness perspective, I think the analytics within the system is kind of where we're going to ultimately land at on being the source of truth. And here we are, we're using words again that we're trying to define. Well, knowing the confidence of your assertion could be particularly useful in the system because then all of a sudden we can, you made an assertion about what was happening in the Palisades during the wildfires, and you said it with high confidence, and now we've got information that conflicts with that. So we might say, well, ooh, wait a minute. Maybe this person is a source or this news source, that affects their trustworthiness for, they said they were really confident about this information, and now we've got conflicting information. And you can start to establish trends. How often does this happen? Does this news source continually give us information, give us assertions with high confidence, and that information turns out to be, there's conflict and there's changes. So that is useful information for the system to have, but I wouldn't put, okay. They're asking hard questions. These can go in lots of different ways. See, you're smiling too, so I'm going to make an assertion. You're enjoying this. You're enjoying seeing me squirm. I think you remember how I talked about there's a before time and there's an after time? I think the answer to this is that we have to take a Bayesian approach. That first observation, you have to take it for what it's worth. You have to take it at face value. If a source, and again, if we're using the news, for instance, if the news makes an assertion with high confidence, we have to take them at face value. Okay, this is a highly confident assertion. And then as the information gets into the system and we get more information, we get updates to that information, we can begin to go back and revisit, well, was that correct, or was that fair to make that assertion with high confidence? But at the same time, we actually will need more information on that particular topic to even be able to come back to that. So I think that's one of the big challenges with these systems. And I see this with a lot of AI systems. A lot of the stuff we're doing in AI with just RAG in general, or how we're dealing with data, the very, very first step is not the same as all the steps that come after it, because there is that naive aspect of you're trying to understand information, you're trying to understand a document, and you have the, I'm getting it into the system, so I don't know a lot about it. But once it's in the system, I do know a lot about it. And of course, Bayesian methods are kind of the mathematical way we deal with these problems. That's something that's also, we've talked about for a long time, is being able to use more Bayesian models to try to understand these kind of topics.
Yeah, and maybe to nail that a little bit home, this isn't just a news thing, but also in a prior episode, I talked to Max on the documentation in Google, and that there are often outdated components or things like where one part of the system was updated and the documentation with it, but a dependency system, the documentation wasn't updated.
Mm-hmm.
So you really have this temporal aspect, one thing changed and the other thing didn't. And with a temporal component and a component that actually maps that dependency, you could make that obvious that it doesn't fit anymore, or it's something is outdated. But in like the current scheme of things, where you just have basically, I embed it once and I use it forever, this just doesn't work. And the same for what we recently worked on is with manufacturers, and they basically have documentation on all of the different parts and all of the different systems, and often different components are swapped out, so the machine doesn't really fit with the documentation anymore. So this is also something you have to consider, and the human part is mostly the biggest point of failure, because when the documentation isn't updated, you can't really update it in your system.
Oh, that resonates on so many different levels, including our own TrustGraph documentation. I think I told you that there's lots of good intentions about keeping it updated, but pretty much exactly what you said. You have these dependencies that you've maybe forgotten about, or it's not immediately obvious, and you don't realize that's there. Knowledge graphs are a great solution for that. You see those relationships, so that once you start to track things temporally, you can look at, when was this last updated, and oh, these two topics are related, and this one hasn't been updated for a very, very long time. Maybe it should be updated. But so many things come to mind when you talk about how information evolves over time and understanding that. And I don't really have a good answer for why we don't do this more now, because the world I came from in a past life, the aerospace world, time was really, really critical. And there was a lot of effort that went into keeping track of this kind of information. Now, it wasn't done with a technology solution. It was mostly done by people, but recording in charts and spreadsheets. And I wish that wasn't the answer, but it really, really was. Because there was a recognition that these issues are really, really important. It's understanding this system failed, and it's related to all these other systems, and we haven't seen anything with this system in a long time. Maybe we should, check it out. Maybe there's something doing wrong with it. Or somebody mentioned to us recently an interesting use case for what we're doing, aircraft maintenance. I know a lot about that one, and that's actually really big. You treat an aircraft almost like a person with their health record, and you look at their maintenance record. Time is a huge aspect of it, because you have here are the things that you do first, and you want to check that, you want to see that checklist, and it can be really important. What's the order you did this in? Did you check that thing that we tell you to do first? Because if you didn't, we probably need to go back to check that. Or, knowing the relationships that, depending on what system you checked, well, maybe we don't need to do that because there's a sequencing order here. So, the sequence of event, the freshness of information, the staleness, because, that's another aspect of it. I remember there was one particular aircraft. I still remember the aircraft really, really well, because I had to travel to go see it personally because it was sick. We had, months and months and months of records. And at some point, it's useful to know what they did 8 months ago, but that was 8 months ago. How many times have they flown this airplane since then? It's not that it's useful, but you have to prioritize the most current information more so than the past information. But but you have to also correlate, is there information in the old information that's not in the current information? And again, that's a really important distinction, that you need that time aspect when you're ingesting all this information to be able to make those distinctions. And as you said, with something like, vector embeddings and semantic similarity, this in situ context is totally lost. And even with knowledge graph relationships, this is not something that's going to be naturally in a knowledge graph either. It has to be manually added, and there has to be a schema or an approach on how you're going to do that. Whether you're going to append the metadata to nodes, properties, relationships. Again, that's time is not. If you look at all of the schemas out there, or ontologies and taxonomies, like the big ones like schema.org or OWL or DVpedia, once again, it focuses on entity resolution. You don't really see a lot about time. And if you actually look at the big knowledge graph database systems, they don't give you a lot of tools for dealing with time either. That's something that you kind of have to add manually.
And how do you see integrating the time aspect into the knowledge graph? Do you see it still as metadata that's attached to nodes and relationships, or do you see it integrated in a different way?
I think the bulk of it is metadata. I think the difference would be, say, with the document that I've been working on for this article, it's an old aerospace airworthiness document called Milhan 516C. If you're looking for something to put you to sleep at night to cure your insomnia, it won't take many pages of it. And it was my life for one of my jobs one time, was really understanding the full breadth of it. And of course, it's going to have a date at the very beginning. It's when it was published, when it went to effect. And I think that would be a relationship in the graph, that this document called Null Handbook 516 was published on, and you would have a literal that would be the date. So that wouldn't be metadata. That would be, an actual relationship in the graph. But, when we ingested and processed the document, that would be metadata. And then when new data or new updates came in that affected topics of nodes or relationships in the graph, that would be new metadata. So I think the bulk of it, metadata, some exceptions. Or for instance, the date that you published this podcast, that would be a relationship. Podcast was published on, and then you would have that date. Or news, this news was published on, X date. And you would actually keep that going forward too. Even if there's new updates, you would probably maintain that, because that would be useful. But every time, all the processing you're doing in the system, that would be metadata. But metadata is really where the intelligence process lives, on processing raw data, is all that metadata you append to it, and understanding the relationships between the metadata and all the insights and analytics and all the connections that come from that data set.
I'm really torn how to differentiate between these two. Like, when is it actually a relationship, and when is it an attribute? How do you put your finger down? Okay, in this case it's a relationship, in this case it's just an attribute which I put on the node.
I think the simple answer is, we're just going to have to make a definition, see how it works out. I think this is going to be a bit of an empirical process of, this is our approach. We think this is the best way to approach it. And again, Bayesian, we make our assertion. I mean, again, that's the Bayesian process. You make your Bayesian prior. This is the system. And you go forward. You test. Was this a good assertion? Was this a good definition? And fairly confident it will change over time. And, philosophically, again, that's why this entire area is so complex is because you just quickly pointed out a simple area of the system we can't really define in a black and white way that everybody's going to agree on. Already you figured that out. And, that's part of my core thesis. None of this stuff is black and white. Facts are not black and white until you get something that just those rare statements, those rare pieces of information that always were and always will be. Those are pretty rare. Everything else is somewhere in between. And when you have things in between, you get 100 people, you're going to get a lot of different approaches. And then you have varying degrees of value out of those. Nobody's going to be, well, I don't want to say nobody. See, again, those are absolutes. People are going to be varying degrees of right or wrong. Again, binary choices. There's going to be degrees of value that come from these approaches. And again, from a business perspective, from a system design perspective, the goal is to drive the most amount of value at the least amount of cost to the user. So that's going to be where the trade-off is. And I think that's why we kind of have to simplify a lot of it, because it can get so complicated so fast. I had somebody ask me the other day about, you worry about duplicates in your knowledge graph. There's a lot of people that get really, really wrapped around the axle on deduplication, and does it really impact the outputs? And oftentimes it doesn't. I mean, if you look at any data store, especially for any large company or customer data set, it can be mountains and mountains and mountains and of duplication, and you can work with it. So how much time do you want to spend on deduplication when your query tools and your ability to access the data allows you to get the value that you need out of it? So, those are part of the system design choices. Yeah, this isn't perfect. Yeah, there are duplicates, but does it affect the outputs we're getting in the system? And how much time are we going to have to spend to do this deduplication? And I think that's a very similar topic to what you're talking about here. You can very, very easily go down the rabbit hole of how to prevent deduplication and spend huge amounts of time and effort into trying to do it. And you go, what did we get out of it?
Yeah, and I think it will depend in the end. What do you put as nodes? What are the relationships? What entities are you using? How are you integrating your temporal data? It's what queries do you actually need to support? Because what are in the end the query patterns of the different users, and this will inform in the end what relationships, what entities, and what metadata do I need.
Querying is an interesting topic in and of itself too, because we find, just take knowledge graphs for instance, you can do really sophisticated query techniques with knowledge graphs. You can start finding, you can start querying on, I want to know the shortest path between two nodes. I want to know the longest path between two nodes. I want to know this kind of path. I want to be able to do this many of hops. There's some really sophisticated graph query techniques out there. And I don't think many people actually use them. And I say that's an assertion with relatively high confidence for me, because I know so many people whose life is selling graph databases, and you talk to them, what do your users say? And we find very few people use those really sophisticated techniques. It's more of, I have a topic and I want to get the first hop of subgraph that's related to that topic. Now, what's interesting is not only do people not really use those sophisticated techniques much going forward, and I'm sure I'm already envisioning now lots of comments of people telling me I'm wrong on this, but once again, we're about to revisit the theme of the before times and the after times. I see use cases for those really sophisticated techniques with complex ontologies. if you have this really complex ontology and you know the data is in this structure, then there are use cases where you might want to say, is this piece of information, is it connected in any way to this other piece of information? And you might want to use some really sophisticated techniques for that. However, with AI, with the language models that we're now using, we extract and build our knowledge graphs to be very, very simple and very, very flat structure. And the reason why is because I guess this is also something. We say graph RAG, but we don't do pure graph RAG. If the graph RAG definition is you're using an LLM to generate Cipher or GQL or Sparkle query, that's not what we do. We actually create mapped vector embeddings, and then we use a semantic similarity search on the query or the request to say, hey, what are the potential nodes that are interested here? Rank those, and then generate subgraphs off of those with pretty standard. There's like an 8 query permutation that gets all the relationships to build a subgraph. So, that's the way that we approach it. And if you approach it that way, all of a sudden, do you really need these complex ontologies? Do I need to know, like if you look at schema.org and all the depth that they go to try to classify websites for SEO, do you need all these, product categories and all these categories anymore? Because we now have a tool with semantic similarity search to know this is the topic that we're looking for. And if we can then correlate that topic to all the other information that's related to it that's in the graph, do we need these complicated ontologies and taxonomies or schemas anymore? And I would argue no. You can still ingest them in. Matter of fact, one of our users is actually working with Stix, which is a very complex ontology in the cybersecurity world for threat intelligence. But I think what we're seeing is that we now have tools that don't require these really complex ontologies and schemas, that we can work with data more at the relationship level. And because of that, I think a lot of these really, really complex query algorithms are even less used. I could be wrong. Somebody could find some really, really, really niche use case for some of those that nobody's ever thought of. But I don't see it at the moment, which also brings me to something that I also kind of think, and that's, do you really need a knowledge graph database? That's a really, really interesting question, because you can store a knowledge graph in columnar tables. There are ways to do that. It's not that hard. Matter of fact, that's what we do with our Cassandra deployment. Cassandra is not a knowledge graph database. So we're actually writing knowledge graph triples into sets of, tables in Cassandra. I mean, we also support mgraph and FalcoDB and Neo4j and some other we're working on integrating, which are more traditional knowledge graph databases, but you don't even have to have a knowledge graph database system to store these kind of relationships and then extract them. And again, it kind of goes back to the maximize value from the system while minimizing the cost that it takes to design it and operate it. And yeah, it's fun to think about complex ontologies. Is it really necessary? And that's something my co-founder Mark actually talks about. I've asked him this question before about why do people develop these incredibly complex ontologies and these schemas when there are ways that you can query the system without it? And I think it's a little bit of people just like it. It's something that people found interesting. It was, you give people a tool, I can do all these other things with it. Nobody ever stopped them and said, well, do you need to? Do you need to do those things? Do we actually need that tool, or is the hammer fine? And I think in this case, we're finding that pretty simple queries suit most people's needs. And we can now do it in a very sophisticated way.
I'm a little bit torn in because I think we get into a space with LLMs that it's become way easier to actually construct knowledge graphs.
Hmm.
But when we use LLMs, typically it's like very free. So any entities, any relationships are extracted and inserted into the graph. And because it has been trained on the different schemas as well, I think LLMs tend to have extraction entities and relationships that are similar to schema.org and the other big taxonomies ontologies.
Hmm.
It's like, I think, more of a simple homegrown solution where you focus on a few core entities, a few core relationships which actually matter for your system, and you restrict it to those. I would actually like to know which of the two sides are you leaning towards? A really open knowledge graph, which is like ever expanding, or like more of the constrained one, which is really tailor made for the system. We are now going into like the black and white thing again.
Um, well, I'll say to address the first point you made about LLMs, one of the things that we found consistent, different LLMs approach this problem, very differently. You're very right in that regard. For instance, the Llama family of models seems to focus more on people. Even if you ask it for entities, you're probably going to get people, and it's kind of hard to get it off of that. Actually, there's a lot of models that if you ask it for entities and conceptual topics, the list will be exactly the same. It's actually a pretty small number of models that we found that can make that distinction. So, I completely agree with that regard. Is that there's no perfect extraction with an L. There's no question about that. And it can also be a little bit specific on the knowledge because you're kind of relying on, is this information in the training set for this model? Here's a good for instance on that. Most LLMs that we've dealt with do pretty well on they do pretty well on Cypher for sure, because there's a lot of stuff about Cypher out there on querying knowledge graphs. So they do pretty good on Cypher. RDF, on the other hand, and you mentioned schema.org, which is based on RDF. RDF, not so much. The most common format that people work with RDF is Turtle, which is the most human readable. And we found LLMs we have not found an LLM that can really consistently output Turtle. And the reason why is if you just do a Google search on RDF Turtle, you'll find blog posts where the explanations are just flat out wrong. And so then you're thinking about like, well, so how think about the training process. Garbage in, garbage out. So garbage went into the system. So how do you fix that? Well, somebody on the human, whatever we're calling all these processes on the back end where humans are manually reviewing the data, whatever buzzword people want to throw at those, somebody would actually have to be able to look at that and know enough about RDF Turtle to realize that this is wrong. And I'm going to wager a decent amount of money that there is nobody on the post-training side of companies like OpenAI and Anthropic and Google who know enough about RDF Turtle to realize this isn't right. Right there, we can see these models are not going to be able to do this consistent, and they're not. And to answer your question, our approach is we're trying to take as broad approach as possible. We don't want to create these very, very, very narrow, complex ontologies and schemas. We've tried to develop TrustGraph from day one to be as flexible, as modular, as open as possible, so people can take these components and very quickly tailor them to their needs. And one of the things that we focus on is what we call cognitive cores, and which is basically a modular component where we've done this extraction. For instance, Mill Handbook 516C. I've been playing around with that. If you go to our GitHub, we have a cognitive core that you can download and reload into the system in minutes that we've already done the extraction on. So you don't need to do that extraction. Part of our vision is that you would be able to very quickly, you could share a cognitive core you've made with me, and I could share one that you made with you. There can be a store where we can download these. You could upload ones that you've made. You could take your entire podcast series and you could create, cores from the transcripts and upload those, and people could use them. Again, though, it's not perfect. It's not black and white. even the cores that we've made for this particular document that I keep talking about, there are some relationships that aren't necessarily connected, that if you're able to really dig into how it's stored in the graph, the information is there, but sometimes there are some missing links. And, that's why in, our kind of future roadmap, there's, working on tools that would be able to give people that ability to, make edits going along. So again, temporally, not only would there be the automated side of that, where you're ingesting new information, and if the information supports the old information or changes it somewhat or conflicts with it, making those observations and recording all that and doing all those calculations, but also where the human can say, no, I manually added this, or I did this because this is my take on this. And again, underlying, there would be metadata associated with all that. Is this an automated process? Was this a human process? Who made this? Who made this edit? Who made this change? Recording all that information. And as you go over time, that enables you to, maybe use the word calculate, but be able to come to a better understanding of what sources, what knowledge relationships you can trust in the system. And again, something we could have spent days talking about how much myself and my co-founder have spent in our lives trying to create metrics to calculate trust. And it's not just us, many people have. And I haven't seen one that has really caught on, because they all have lots of pros and cons. And the cons often, they often hurt the pros so much that it's difficult to use them, which again, we're getting back to, what's the most amount of value we can get from these systems, at the least amount of cost. And in this kind of, and I kind of think about it in the Moby Dick perspective, the white whale. Some of these are white whales that people spend their entire careers chasing after these topics. What's trust in a number, or what's risk in a number? And they dedicate decades to it, and they do good work, but they never quite get there. And I think, that's really important to realize, how many of these topics are white whales? And I think there's a lot of white whales in AI right now. People are chasing these topics, which we're never going to get there. And we're much better off accepting that now and saying, we're never going to get to this point of perfection. So what are approaches that are usable? Or, how do we begin to build on top of these processes and approaches to get the necessary amount of value out of it, commensurate with what we're putting into it?
I think that's actually also one of my biggest pet peeves in the space, that tools always just continue adding on features until they are basically useless. I think we are lacking stuff in the space, like open source project, but also software products, where they just say, this is the feature set, we do one thing really good, we now have a feature set, now it's only maintenance, and we don't go beyond that. And I think there are a lot of tools who just, they have found it, they are really great solutions, and now they just start adding like useless stuff for additional use cases. And I think we need more tools who just say, okay, this is what we are doing, we are really great at that, and we are not going beyond that.
Well, that's kind of a bit of why we haven't worked on lots of connectors for TrustGraph. So if you look at some of the other frameworks out there, agent frameworks, different frameworks, they have lots of connectors for all the backend systems that your enterprise might be using. They have, if you look at, they have a page that you can scroll and scroll and scroll, and there could be 50 different connectors, even more. And that's one of those situations that once you go down that road, it's exactly what you said. You will spend so much time maintaining all those connectors. Every time those dependencies now update their system, or they update their API, or they make a change or add a new feature, now that's where all your time is going, is maintaining those connections. And so, to your point, you really focusing on the thing that you do well. And that's where we've been trying to focus, is on the things that we do well, and not focusing on all those other connectors. But I think there's also a little bit of sometimes an unrealistic expectations from customers that the product should do everything, and don't really think that, oh, for this to do everything, it's probably not going to do anything particularly well. So it's one of those. I think it's interesting. When I was growing, people had Swiss Army knives. Do you remember those? Because I don't ever see people talk about those anymore. It was a big deal to have a Swiss Army knife.
I still have them.
But do you ever use it?
Yeah, because I often lose stuff like
Okay,
wine bottle openers and stuff like that.
but I think you would agree that Swiss Army knife looks really cool. And from a marketing perspective, oh wow, it's a dream because look, it does everything. It does this, and this. You can make this, amazing content about all the things it does. But if you try to use it, you realize that it, yeah, you could use it to open a bottle of wine, but if you have actual wine opener, you're going to choose every single time to use that because it's the better tool. It's better because it's designed specifically for that. So you do get these, one side, you get these, tools. We do it all, but do you really do it well? And wouldn't you be better off just doing, taking the one that does the one thing really, really well?
Yeah, and I think that really leads into another topic we talked about before, the API meshes. That you said that a lot of AI is actually just connecting different APIs and actually calling them. How does that actually fit together with that view that tools should be specialized? Because when I use specialized tools, I tend to have more of like different modules, different services, different APIs, whatever, that I have to call.
I think the first topic is that so many of the frameworks or even platforms that we see out there is when you really dive into the code, that's all they are. It's it's glue code. Because what is glue code? Glue code is connecting two different services together, and when you have everything as an API service and you just begin to connect them together, yes, you kind of built this really complicated mesh network in a way, but then how does that network operate on its own? So you've kind of created this mesh network with all these API connectors, or even more linear systems, more point to point. So what controlling all that network flow underneath it? And if you're not worried about performance, if you're not worried about having lots and lots of users and lots of data, maybe you don't care. And I think, that's one of the things I've seen in AI is so much of what you see is demoware. So much of it came out of a hackathon, something that people could build over a weekend, something that came out of a notebook, a collab notebook that people could really quickly get their hands on and, within hours say like, oh, this does this, and it's really cool. But what does it take to take it beyond X? Take beyond X. How do you take this to having millions of concurrent users and having petabytes of data underneath it? And then what is the user experience? When you create these these mesh network with no control underneath it, you create these bottlenecks. Somebody's going to be waiting. I think about, a state machine analogy, with an elevator in which it has to transition from, if I'm on the 4th floor and I'm going to the 12th floor, if somebody else is trying to go down, it's not going to stop. It's going to take me to the 12th floor and then come back because that's just the rules of how the states transition. And, that's something that we just accept for an elevator. That's just the way it works. But customers for software products don't tend to have that patience when they're waiting because, oh, somebody else's requests are going through and you have to wait because that's the way the system has been designed. And to get at your question, I think there needs to be more of an understanding of what software infrastructure really is and why it's important. And there've been a couple of things that I found shocking over the last year because I used to go to a lot of AI events here at SF. I haven't had as much time to do that lately. And when you say words infrastructure, so many developers now look at you like, what do you mean? Do you need AWS? What do you mean? What do you mean infrastructure? What does it even mean? And, TrustGraph, uses Apache Pulsar as our backbone. And I'll say things like, we're using a pub sub backbone. And this is, I'm not kidding on this because I actually count. In the last year, I've met fewer than 5 people that knew what pub sub was. And this is Silicon Valley engineers who are building an AI. That is no joke. That is no exaggeration. Because I count. And they tend to be actually people from some of the people that I've met that actually knew that had actually were visiting San Francisco from somewhere else. And I'm just I'm just flabbergasted. I'm dumbfounded. And I think that's because, and I'm trying not to derail us here because I'm about to spin up on a topic I could just keep on zooming on, is that we've, over the last decade or so, we've decomposed software down to the smallest component possible to get it into a Jira task. And that's so many software engineers alive now, is they work on a very particular set of features, maybe one feature in this one service and this one overall stack, and they don't really touch anything else. So it's not that they understand these topics. It's not that they're not technical enough. It's just that they don't ever see any of this stuff. They don't ever see it. They don't ever think about it. And if you spend too long in these worlds and these very, very granular topics, you kind of lose the ability to see the big picture because you just haven't flexed that muscle. You lose that ability to think like, oh, wait a minute, how does this affect the site reliability team? What do those people even do? What's the stack underneath this? How does my service relate to other services? What are they actually running on? How do we deploy these services? How do we how do we have backups of these services? How do we have failover? How do we do any of these things? And there are so few people that think about those problems, and oftentimes companies don't invest in it because it's not a feature. It's not something that they can directly market and sell to the customer. So you always see it in people that have worked in environments that have, high reliability requirements. So either, highly reliable requirements, high availability, you can't lose data, data loss is really, really critical. So unless you happen to work on software that touch from those systems, you've just kind of forgotten about these issues or haven't even thought about them. And, I think we got to start thinking about these problems at a more holistic level, a bigger picture, the systems level of how these systems integrate to each other. Because, if you build a really, really reliable, flexible, modular system where you can plug tools in, then you can build the best tool possible. It plugs right in. And the thing is, this stuff already exists. It's out there. That's why we chose Apache Pulsar. Apache Pulsar is fantastic. I mean, it's got all of the nines in reliability. It's got all the modularity and flexibility. With the way we use it in TrustGraph, you can very easily take a software module and hook it in to Pulsar, and all you got to do is you either publish the key, you define your queues. If you're trying to subscribe to a queue that's already there, you just subscribe to that queue. If you want to create a new one, you just create a queue and start publishing to it. It's crazy simple how simple it is to scale up on these services so that you can focus on building this one tool that's great at what it does. But you have to have that foundation there. And that's what I see totally lacking in so many of these frameworks that just focused on the higher levels of the stack. They focused on, if you're thinking about a building, a high rise, they focused on building out all the floors first, all the office space and all the bathrooms and all the kitchens, and they're great, except that what's underneath it? There's nothing here. Well, what happens when we try to scale it up? It collapses. And that's kind of one of those big picture topics that honestly, that's why, I've been doing more stuff like this, why we started doing our own, podcast series where we interview people and why we've been more vocal is to try to shift the narrative in this space to say, time out. Yeah, this stuff you guys are doing is really, really cool, but you're going to hit a brick wall. Actually, you're not going to hit a brick wall. You're going to hit an impenetrable wall that you can't tunnel through, you can't tunnel underneath, and you can't climb it. You're just going to be stuck. And the only way to get around that wall is going to be to turn around and go in a different direction.
Yeah, I think it's partly also there aren't many people who actually get to see the problem and come up with the requirements for a solution. What do I actually optimize for? But the large majority of developers actually sit at the end of the process. They get told what do we have to
Yeah.
achieve, or like rather the solution which they have to program, and aren't really part of the decision making, so they really can't learn it. And one project I think which is really interesting to study in that domain is, for example, Tiger Beetle, which is an open source database tailor made for financial transactions.
Mhm.
And I think this is such an interesting area because you can really see when you go through the docs and their blog posts, like how they are optimizing for that specific problem. And they really go from problem to architecture to like the specific implementation, which is really interesting to read through.
No, I completely agree. And, this is what happens when you design companies where you want to decompose essentially people into replaceable cogs in the machine. And, that's kind of what we've ended up with Sweeze is that, to big tech companies, software engineers aren't people. They're 5 years experience with Python and this particular stack for this particular use case. And we've decomposed it such that if this employee leaves, we can just slide somebody straight in and there's no change. We don't see any change in our productivity. But you do that long enough, you get people with 10 years experience, 15 years experience, and as you say, they haven't touched, other parts of the system. And it's not their fault. It's not because they're not interested or they're not capable. It's just in a lot of cases, they're not even allowed or they don't even know that stuff exists. I've seen that time and time again in tech companies where there are teams doing work that you didn't even know about. I had times in my aerospace career where I found out that there was a row of people, 2 cubicle rows over, doing the same thing I was, and we didn't know about each other. Or they're the team across the hall that are doing the same thing for a completely different set of people and just found out about it by accident. Shouldn't we be working together? You go, yeah, you probably should, but we're not gonna. You go, isn't that gonna cause problems? Aren't we gonna step on each other's toes and something we may do might break something they're doing? Yeah. And that happens a lot. When people are doing all this work in isolation, but that's I mean, all of a sudden, we're now to, this is a rant against company capitalism. When you prioritize decomposing these tasks to that level, that's part of the problem that you're going to see. And it's also short-term thinking. I've seen that change a lot, through my career. Uh, I'm a bit older than I look. To maybe my benefit or detriment, I don't know. And I think about how engineering was approached when I first started working, and it's radically different now. I remember, I started as a junior engineer, and you had a senior engineer and a program manager. And part of the senior engineer's job was to be the tech lead, but was also to mentor the junior engineer. That was part of their job. That was understood to be part of the job. That's why you have senior engineers and junior engineers on the team so that the junior engineers get experience and they learn. And that is something I haven't seen for well over a decade now, this structure where we recognize that people need to learn and grow and be exposed to new topics. Instead, we've chosen to value people that are the absolute expert in their very, very, very narrow niche. And then we expect them to be able to do all these other tasks outside of that. Because, well, they're the best at this. Yeah, they're the best at that very, very, very narrow niche. That doesn't mean they're going to be able to figure out all this stuff that there's their counterpart that's been doing it for 10 years and doing that only one thing. So what can we possibly expect? If I did this if I was an expert on a single graph query algorithm and Cipher, and all of a sudden, you ask me to be able to design a SQL database with X amount of reliability, and you go, well, he's an expert in knowledge database systems. Well, no, I spent 10 years doing this, and well, I didn't, by the way. You'd say that I spent, 10 years on this very, very narrow algorithm for this one system. I'm probably not going to be successful in applying that to something else when it takes somebody else doing it for 10 years to know that. And, that's a big challenge I see in the tech world right now, which even corresponds to, what we're doing from an information level. It's the same thing. You're taking information in these small chunks, whether it's social media or now using vector embeddings, you're taking this information and removing it, and you're losing all that context. You're losing all that context of how it was initially connected within these systems, the relationships, the underlying relationships, how those relationships are all connected. And you need all of those connections to see the big picture. And, I think, archaeologists talk about this a lot. If you study how, because that's a term I use, in situ context. Archaeologists talk about this a lot when they do archaeological digs. That's why, they're so careful. They have these little like brushes, actually like paint brushes where they brush away the dirt, because they're so terrified of removing an object from its context, because that's all the information you have. Once you find an artifact and you take it out of the ground and you walk away with it, you've lost that context. Now you can't say, well, it was found in this layer with these other artifacts, so that we can begin to say, well, these probably come from the same time period or the same event, or how are they related? Because now you're holding it in your hand and you've walked over here. You don't have, you've thinking about time again, you can't unwind that. You've removed it. You removed its in situ context. And that's really applicable here in the AI space. Well, if you're just doing vector RAG, that's the same thing. You're taking these words or these phrases and you're removing them from the in situ context. And once you get them out of that, they take on different meanings. And if you don't have a way for reconnecting those relationships from the original context, that's how you get that's how you get, I don't want to say misinformation, but you can get inaccurate statements. You can get statements that don't quite make sense. You can get missing details. And all that stuff is really difficult to spot unless you really read every single statement at the word level with a lot of understanding about what you're looking at, which is kind of one of the articles I'm working on now, is, comparing these results and saying that on the surface, they all look good. To somebody that's not trained on the topic, they all look good, but there are different levels of quality, for lack of a better term again, on how we measure these things that we would attribute with each of the responses from the different techniques.
Yeah, and I think what's my biggest obsession in the space is actually more learning patterns, because I think AI especially is a field we steal a lot from different areas, like from data engineering, from platform engineering, from like in general like systems engineering as well. Like it's like a grab bag, you put it all together. And I think when you actually learn the patterns behind it, you can make way better decisions about like how different systems should be put together. And I think that's also partly why I want to do the podcast, because 1.5 hours of conversations, I think you learn a lot from a person.
Well, that's an interesting topic too, because I've gotten a little frustrated, and less so now because I understand what it's coming from, about how much I see what I call reinventing the wheel in AI. I see so many people, for instance, building RAG systems when there are so many solutions out there. There are many open source RAG solutions. There's many products. And I go, why? Why are you building it again? Why are you rebuilding it? And what I learned is it kind of goes back to where we were talking about a little bit ago, is people, software engineers' jobs are so narrow now. They're they're doing these projects just to learn. They're doing these because they're so bored in their jobs. They don't get to touch any of these other systems. And a lot of people are kind of recognizing that. They're going, wow, I'm only working on this one really narrow topic every single day. And I want to try some of these other things out, which, then though, there's some interesting effects to this is that now we see all of this code that's out there that's kind of just it's a playground. People are playing with ideas that they're experimenting. And from an AI perspective, we go at least up until now, and some people still think in this scaling sense of pre-training more and more and more and more is going to solve all of our problems. So they could be looking at this going, well, this is great. All this new code is great. I don't think so. I think this is a garbage in, garbage out solution because now we have more code than ever before because so many people are doing these experimental projects and it's easier now than ever before to do it. At one time, you would have to do a lot of research on how to use all these tools and you'd have to manually write the code. Whereas now, you don't even have to go to Stack Overflow to copy and paste. You can get an LLM to generate a lot of the code for you. And it's working code. It may not work the way you want it to, but it's working code. So we see more code than ever before is getting pushed out to somewhere like GitHub than ever before. But if you're trying to train a model to be able to write code, what coding practices do you want to reward? What are the best coding practices? What are the best algorithms? Which means, how do you even measure that anymore? We're going to come back to some software engineers going to have to be able to look at this stuff and make a determination of A is better than B is better than C. And then you go, well, how did you make that determination? And a lot of it can come back to being personal opinion or personal philosophy. So it's
But I think that's actually also an upside of generative AI. Because I can now code much faster, I can generate 4 different options to solve the same problem, write the different algorithms, and test them.
It's true. I don't see many people do that, though. See, my problem, so I don't think a lot of people test their code. Dude, I mean, that's my observation. Again, that's an observation. And over time, that observation may or may not have enough supporting assertion. Excuse me, that's an assertion. That's my assertion based on my observations, which I can't support right now. So that would be an assertion, is that I don't see a lot of people doing that rigor. I don't see people really, testing that, because it's a lot of work to do all code coverage and all that testing. And it's not fun. It's not fun. But then you get into, are these the most effective ways to do this? I think you're right. There are people like yourself that see this as an opportunity to, wow, now I can quickly do this 3 different ways and see which way I like the best. Or I think the more common approach is LLM gave me code, I copied and pasted, I'm on to the next thing.
Yeah. I think if we could drag this conversation on for like an hour more, I think we have to go to the outro. Otherwise, I take too much of your time. What is next? What can you already teaser? What's like on the horizon for TrustGraph? What are you guys building on?
Well, the thing that we're really focused on right now is our users have asked us about better ways of managing data. People want to be able to how they load data in the system, be able to granularly select what kind of topics and data they have loaded so they can unload, reload, do it dynamically. Being able to, have this very reliable, very modular, infrastructure running at all times and being able to control what's deployed in it. So they want more granular tools and that. So basically, infrastructure tools. And then, though, we want to really dig into what we're calling Temporal RAG, which is going to be a big effort. It's going to be, I kind of hinted at how we want to approach it, that, facts, observations, and assertions. I think we're going to start with trying to keep those definitions.
So what can we take away if you want to apply this in production? I think first of all, building specialized tools rather than building one size fits solution is, I think, a very interesting approach. I think this has been a little bit lost in the ML and AI and data space as well, that in the beginning tools focus on one specific problem and solve it masterfully, but then they go broader and broader. And that's okay for a bunch of different domains. But I think in a lot of cases, it would probably be better if you stick with that area and actually try to master it and become the default tool, the de facto standard for it, because you're so good at it. And I think this has been a little bit lost, that you have single purpose tools, domain specific applications, which focus on one specific problems and focus on the core functionalities, develop clear interfaces for that, optimize the performance, be a domain specific solution, and maintain the independence. And I think with a lot of other tooling and software solutions, it's overloading a single tool. They get generalistic, so they become like Excel, which in a lot of cases is just like you don't even know what to do in it anymore, and it forces a lot of generic data use on top of you, and the integration also becomes like overcomplicated in a lot of cases. So instead of trying to build an all-in-one solution, I think you should think about like building specialized tools. And I think this framework is also really interesting for software startups. Like, where does it actually pay to invest in specialized tooling as opposed to adopting something more general? And the tech stack decisions nowadays have become more and more complex because we have more and more open source solutions out there, which are very good solutions for a set of problems. The question is whether it aligns with your specific problem at hand. And I think as engineers, we often opt into like building something in-house, something specialized, but this comes with a lot of cost and with a lot of complexity down the road, because you might build something specialized for the moment, but this also has to be maintained over time, and it has to be adjusted. Features have to be added to the use case. And I think this is something that's often ignored. And these are just tasks which are often not directly related to the specific problem you're solving for the business or for the end user. And I think specialized tools or specialized software have a place, but you should be really clear about what their purpose are and why you are building them and why you can't use something that's already been built before by other engineers. And only if the reason is like, okay, no one has done it before, or we need something so different to actually solve the problem at hand, then you actually think about, okay, I'm building something in-house. I also love Daniel's point on like robust infrastructure. I think I'm always a little bit torn like that. Like, they have built a lot on Apache Pulsar and Cassandra. So both of them are very scalable technologies. I also talked to Daniel's co-founder, and he recycled a lot apparently from a previous project. So I think like take it with a grain of salt whether this infrastructure is the right one for you. Yes, it's scalable, but at the same time, they have built with these technical components before. So I think always like the best tech stack to build with is probably the one you have built with before, because you already have the experience. You know, like how to set it up, how to put it together, what are the downsides, the performance characteristics. And especially at the early stages, you don't want to spend your time thinking about the technical components and how they work. You want to spend your time thinking about the problem and how to solve it. And when you go with solutions you haven't, or technologies you haven't used before, you will spend a lot of time actually figuring them out and mastering them. So this is an extra caveat. And then actually, once you hit performance issues, then you can start to think about, okay, I'm doing a migration, I'm switching to a more powerful tool. But at that point, you're likely able to hire more help, or hopefully you have a little bit of more time on your hand that you actually can build a better system. When we look at the knowledge graphs, I really like the favor simplicity, so keep it simple and keep it modular. So rather than relying on really complex and nested ontologies, like for example schema.org, which has evolved over years, try first to build something simple, design a graph with a few core entities and a few core relationships that capture the essence of the domain, and then over time add more and more to it. You might also end up at something similar to schema.org. A lot of people have spent a lot of effort figuring out this schema, but for you want to build something that works for your domain very fast, but also in a way that you can wrap your head around it. And what I always like to say, like, a complex system that works has likely evolved from a simple system that worked before. So start with a simple system and adopt or integrate complexity over time when it's necessary, and not just for the sake of complexity. So when you look at a new domain, define the core entities, design for flexibility, so still keep it extensible. So this is also something like maintain optionality when you're building stuff. When I am thinking about, okay, how am I structuring a project? What am I implementing? It's always interesting to think about, okay, how can I set it up in a way that it's easy to extend it, that it's easy to add new functionality or features later. And when you manage to do that, it becomes easy to adopt something more simplistic, because you know, like, when I have to make it more complex, I can't do it down the road. And yeah, I think that's it. So let me know what you think of it. I would love to hear your comments, reviews, negative or positive. Also, if you liked it and you've listened for like 8 minutes now to hear me brabble in this post review, leave a review on Spotify, on Apple Podcasts, or wherever you're listening. Leave a like on YouTube, it helps a lot. And also recommend it to your friends, recommend it to your colleagues, to your students, and that's the best way to make it grow. And otherwise, I will catch you with another episode on Knowledge Graphs next week. See you then.
Pretty simple at the beginning. My inclination is to try to keep those simple going forward. And, they can be pretty sophisticated, analytics algorithms, underpinning how we calculate things like trust or freshness going forward. I think that we have to try to simplify these kind of things so that everybody can, there can be some sort of consensus, or otherwise, I don't think it's going to, like I said, I've seen this a lot in people chasing the white whales of trust indices or trust metrics or even risk. The more sophisticated you make it, the more complex you make it, the less buy-in you get, because people can kind of point to exceptions to every rule. So really kind of starting with a really solid foundation of how we want to go through this. And also, it is going to require a Bayesian approach, because like I said, there's the before times and then there are after times. Once you get data into the system, you can start thinking about time differently than what happened in the past, which is something I think we're just going to have to accept. Is we can't necessarily understand past information at this point with the level of granularity we will be able to going forward.
Nice. And if people want to start building the stuff we just talked about, or want to build on top of TrustGraph, where would you point them?
Well, and this backwards or TrustGraph.ai, that'll point you to our GitHub. So that's where we primarily do everything. Is at GitHub. We have our Discord. We actually have our own YouTube channels where we do tutorial videos. I actually, talk to other people in the space as well. But yeah, Discord is always a good way to get in contact with us, talk about other people and some of the things that they're working on. We just recently did a poll, and that's why those are the things people were interested in. There were a couple of things that I really thought people would be interested in, and so far we haven't seen it. I kept boy, I've been thinking about taking a multimodal approach to this for a while now, and so far people just that hasn't been what they're looking for. I don't really have. I'm sure there's somebody out there that's looking for that and is going to go like multimodal, agentic RAG. Yes, I'm interested, but that's not really what our user. No, nobody's that wasn't what anybody voted for. Surprised me. What are my suggestions?
So what can we take away if we want to apply this in production? I think, first of all, building specialized tools rather than building one-size-fits solution is, I think, a very interesting approach. I think this has been a little bit lost in the ML and AI and data space as well, that in the beginning, tools focus on one specific problem and solve it masterfully, but then they go broader and broader. And that's okay for a bunch of different domains. But I think in a lot of cases, it would probably be better if you stick with that area and actually try to master it and become the default tool, the de facto standard for it, because you're so good at it. And I think this has been a little bit lost, that you have single purpose tools, domain specific applications, which focus on one specific problems and focus on the core functionalities, develop clear interfaces for that, optimize the performance, be a domain specific solution, and maintain the independence. And I think with a lot of other tooling and software solutions, it's overloading a single tool. They get generalistic, so they become like Excel, which in a lot of cases is just like you don't even know what to do in it anymore. And it forces a lot of generic data use on top of you. And the integration also becomes like overcomplicated in a lot of cases. So instead of trying to build an all-in-one solution, I think you should think about like building specialized tools. And I think this framework is also really interesting for software startups. Like, where does it actually pay to invest in specialized tooling as opposed to adopting something more general? And the tech stack decisions nowadays have become more and more complex because we have more and more open source solutions out there, which are very good solutions for a set of problems. The question is whether it aligns with your specific problem at hand. And I think as engineers, we often opt into like building something in-house, something specialized, but this comes with a lot of cost and with a lot of complexity down the road, because you might build something specialized for the moment, but this also has to be maintained over time, and it has to be adjusted. Features have to be added to the use case. And I think this is something that's often ignored. And these are just tasks which are often not directly related to the specific problem you're solving for the business or for the end user. And I think specialized tools or specialized software have a place, but you should be really clear about what their purpose are and why you are building them and why you can't use something that's already been built before by other engineers. And only if the reason is like, okay, no one has done it before, or we need something so different to actually solve the problem at hand, then you actually think about, okay, I'm building something in-house. I also love Daniel's point on like robust infrastructure. I think I'm always a little bit torn like that. Like, they have built a lot on Apache Pulsar and Cassandra. So both of them are very scalable technologies. I also talked to Daniel's co-founder, and he recycled a lot apparently from a previous project. So I think like take it with a grain of salt whether this infrastructure is the right one for you. Yes, it's scalable, but at the same time, they have built with these technical components before. So I think always like the best tech stack to build with is probably the one you have built with before, because you already have the experience. You know like how to set it up, how to put it together, what are the downsides, the performance characteristics, and especially at the early stages, you don't want to spend your time thinking about the technical components and how they work. You want to spend your time thinking about the problem and how to solve it. And when you go with solutions you haven't, or technologies you haven't used before, you will spend a lot of time actually figuring them out and mastering them. So this is an extra caveat. And then actually, once you hit performance issues, then you can start to think about, okay, I'm doing a migration, I'm switching to a more powerful tool. But at that point, you're likely able to hire more help, or hopefully you have a little bit of more time on your hand that you actually can build a better system. When we look at the knowledge graphs, I really like the favor simplicity, so keep it simple and keep it modular. So rather than relying on really complex and nested ontologies, like for example schema.org, which has evolved over years, try first to build something simple, design a graph with a few core entities and a few core relationships that capture the essence of the domain, and then over time add more and more to it. You might also end up at something similar to schema.org. A lot of people have spent a lot of effort figuring out this schema, but for you want to build something that works for your domain very fast, but also in a way that you can wrap your head around it. And what I always like to say, like a complex system that works has likely evolved from a simple system that worked before. So start with a simple system and adopt or integrate complexity over time when it's necessary, and not just for the sake of complexity. So when you look at a new domain, define the core entities, design for flexibility, so still keep it extensible. So this is also something like maintain optionality when you're building stuff. When I am thinking about, okay, how am I structuring a project? What am I implementing? It's always interesting to think about, okay, how can I set it up in a way that it's easy to extend it, that it's easy to add new functionality or features later. And when you manage to do that, it becomes easy to adopt something more simplistic, because you know, like when I have to make it more complex, I can't do it down the road. And yeah, I think that's it. So let me know what you think of it. I would love to hear your comments, reviews, negative or positive. Also, if you liked it and you've listened for like 8 minutes now to hear me brabble in this post review, leave a review on Spotify, on Apple Podcasts, or wherever you're listening. Leave a like on YouTube, it helps a lot. And also recommend it to your friends, recommend it to your colleagues, to your students. And that's the best way to make it grow. And otherwise, I will catch you with another episode on Knowledge Graphs next week. See you then.